The effect of corrosion on the quality of repair of aluminum alloy A5083 H11 by bonded composites. In this paper, the simultaneous effect of corrosion and cracking on the performance of the bonded composite parts repaired in aluminum alloy A5083 marine structure was investigated using three-dimensional finite element method. Two patches made of carbon epoxy and boron epoxy bounded on a corroded plate with and without crack were tested under different applied loads. The effect of both corroded and cracked marine on damage of the adhesive A5083 was also highlighted. A simulation was performed using a finite element tool and the mesh was found. As a result, we plotted the evolution of damage ratio versus the applied load in the case of corroded plate without crack, the evolution of damage ratio versus the applied load in the case of a corroded and cracked plate, and the evolution of the G integral as a function of the applied load for the cracked and corroded plate repaired by both patches compared to that of the cracked and corroded plate not repaired. The following conclusion has been drawn. Increasing the applied load implies an increase in the damage ratio of the adhesive. The repair with both types of patches, boron epoxy and carbon epoxy, gives an acceptable repair performance for case of load lower than 300 megapascal without risk of adhesive descent. For stable load higher than 300 megapascal and the case of the repair of corroded and cracked A5083 aluminum alloy structure, it is recommended to use a boron epoxy patch since it provides a better performance and therefore longer service life compared to a carbon epoxy patch.